Good day, guys. In today's lesson, we'll be looking into mathematics, a topic in mathematics called limit and continuity. And so, what is limit and continuity all about? So, in limit and continuity, we're kind of expecting your questions or problems to be in these basically two forms. One, you might be asked to prove these limits. You get? And secondly, you might be asked to evaluate the limits. So basically two of them. So proving of limits and evaluation of limits. And we'll be doing both of them in this segment of this video. So let's look into it already. This is limits. It's basically called limits and continuity. So now let's find the proving part of this limit. How can you prove a limit? We prove a limit with this formula. It says this. So look at this formula carefully. This is the formula we make use of in proving limits. And it states line f of s minus the limits less than epsilon for all 0 less than s minus t less than this. Did you get it now? So this is the formula you actually use in proving a limit. Now, for instance, we have been asked to prove these limits. I, the proof limits of 2x plus 3 is equal to what? 5 as x tends to what? Okay, x tends to 1. So, having asked this, what you have to do, you get this formula back. So, let's look at this formula. This means, okay, now, let me explain this. This is the limit. This, everything here is a function. And this is a continuity. So this is a function, this is a limit, and this is continuity. Having known that, now the function, this is like f of s is the function. We'll take this and substitute here. Now something like this. Line 2x plus 3 minus the limit is what? 5 less than epsilon, elements of this, for all 0 less than x minus c. And now our c now what's 1, which is less than this. So, having known this, now the main aim of this proof of limits is actually to find the relationship between this, between here and here, making use of this epsilon actually. Trying to find the relationship between this and this. Now, having done this, let's work on this. We now have this to look like this. Okay, we now have basically we now have 2x plus 3 minus 5. Now, like I said earlier, we are not making use of all these you are seeing. The thing that we make use of here is this epsilon. That's in finding the relationship. Do you understand? So basically, just all this we don't need it. So we don't need to write all this and bring them down here. So from here, work on this again. This will now be what? Plus 3 minus 5 is actually what? Minus 2. We now have this to like 2x minus 2. Right? So this will have it actually. Opposites. Now at this point, what can we do actually? We can factor out, we have 2 here, we have 2, we can factor out 2. And we factor out 2 here now. We now have 2 to the out. 2 go here, we now have 1x. Here is just minus 1. And basically, most times in proving these limits, You're gonna find out that what you get here, now this will always be targeting this. This should be an indication that you're on the right track. This, you have x minus 1 here, you have x minus 1. So these are what we need here. These two. Do you understand? So then we talk about the relationship. The relationship. Which entails that, which says that, okay, now, having this now, we have 2, this, you can equal to what? You can carry that to, come on, put it here also. We have this 2, can basically call it, like, I call it sigma to my 2. It helps me actually, you get, so you can call it anything. So this, what we have here, what we factored out can be equal to this. So now this is equal to what? 2 sigma, I call it. Do you understand it? Okay. So now, in finding the relationship, we now talk about, we now say that epsilon is equal to what? 2 sigma. Do you get it now? Now, making this the subject, we now have this to be equal to what? Epsilon over 2. And this is our answer. So the aim of this is trying to find this relationship to say that this is equal to what? Epsilon over 2. So I believe this clear to you now. Now let's work on one more example and it should go for now. Now, in a case like this, we have to prove the limits of, remember, x squared minus 1 all divided by x minus 1 is equal to, let's make it of, okay, is equal to 2 as x tends to 0. Now, in a case like this, looking at this, what can you possibly do now? We have this, and this representation that it actually given in proving the limits. So what do I have to do? Let's expand this, and then we're going to get the function here. And let's bring that now. Watch. X squared minus 1 like this. When you expand this, this same thing as x plus 1 and x minus 1, because x squared, if you open two brackets, x give x two of them, then minus 1 and plus 1. The times is now x times x is what? X squared. X times minus 1 is what? Minus x. 1 times x is what? X. And plus 1 times minus 1 is what? Minus 1. We now have something like this: x squared minus x plus x minus 1. And this will take this out. We now have x squared minus 1. Have you seen it? So this is basically what you have to do. So at this point, we now have this and this. Right? Let me clean this. We now have this and this like this. And we can then bring this thing down and put this x minus 1. And this, we cancel this out. Leaving us with was x plus 1. So x plus 1 is actually the what? Function. So when substituting back in the formula, so having gotten this to be x plus 1, we now have limits as x plus 1, okay, just it is equal to 2, x tends to what? 0. And sorry, there's a mistake actually. This tends to 1, this tends to 1, but the values are correct actually. So now, looking at this, let's bring that formula back. Now, basically, we want to use line f of x minus the limits less than epsilon for all 0 less than x minus c less than this. Right? So let's substitute this value now. Now this will be what? X plus 1. Now x plus 1. The limit is what? 2. right? Okay, less than sigma, less than epsilon for all 0 less than x minus our continuity is what? 1. Now this less than this. So basically, like I told you earlier, we don't need this for now. It will help in determining the relationship just as. So for now, let's expand this. For now, this look like x plus 1 minus 2, right? So for now, this to look like this. X plus 1 minus 2 is actually minus 1. Now this is what? Minus 1. Right? So having this, now look now. Like I told you, the value here should always be carried with the value here. We have x minus 1 here, we have x minus 1 here. And basically, there's a visible one here, right? So when you factor that one out, you now have this look like 1x minus 1, right? So this is what you actually, in finding the relationship, we say that 1 is equal to now, first of all, say it's equal to what? 1 sigma. Have you seen it now? Then the relationship entails that 1, okay, it entails that epsilon is equal to what? 1 this. And when you make it such the formula, we now have it look like epsilon over 1. And basically, this is our answer. So this is what we're here limits and continuity. This is how to prove the limits. So we'll actually what do you call it, evaluate the limits in our next class. So for now, this is see you in my next video and bye for now.